Welcome everyone. We are now into the third lesson of chapter 12, numerical methods. So far we have learned the trapezium rule. Now, trapezium rule is used to find the area under the graph. Then we have learned the graphical method and the intermediate value theorem over here. Now, trapezium rule, which is used for numerical integration, whereas the graphical method is used for numerical solution of equation. So today I'm going to teach Newton Raphson Method. This one. Now, Newton Raphson Method is also under numerical solution of equation. But this method will give a better approximation of a root than graphical method. Now, as shown in this graph, graphical method is able to show you that there is a root between 1 and 2. If you look at this graph, can you see there's a root here between 1 and 2? But graphical method cannot be certain whether it is 1.5 or 1.6 or 1.7. We are not sure. So the Newton Raphson method is a method for finding successively better approximation to the root of a complex function. Successively means by using this formula, doing it repeatedly. Alright? Successively means by using this Newton Raphson formula, doing it repeatedly, we will get approximation closer and closer to the root here. Right? Now let me show you the visual representation of the Newton Raphson method and how the formula of this method is formed. Alright, let's say you are given a function as shown in this graph, and you can see that there's a root here. Now let's say the root is alpha over here, right? So we will give the initial approximation. Now the initial approximation usually is an integer closest to the root. As for example, if the root is here, we can use 2 as the first approximation or initial approximation. We can also use 1 as the initial approximation. So for this case, let's say we use x0 as the initial approximation. Now x0 represents a number. If I substitute x0 into the function, you will get fx0 here. So if I draw a tangent at this point, f0, x naught, f naught here. I draw a tangent passing through this point. This tangent will intersect x-axis at x1. x1, we call it the first approximation. This value, you will see that it is closer to the root than x naught. Now x naught, the value of x naught is given to you. Usually in the question, the value of x naught is given to you. How do we find this value, x1? Now to find x1, we actually use the gradient of this tangent. The gradient of this tangent is actually f prime x naught. Means you find the first derivative of fx and you substitute x naught into f prime, you will get the gradient of the tangent. Now at the same time, the gradient of the tangent is also the ratio between f naught, this one, over this distance, x naught minus x1. In other words, if I divide the vertical height here with this distance, x naught minus x1, I will also get the gradient of the tangent. So, if you look at this equation, the gradient of the tangent by using the first derivative and the gradient of tangent by finding the ratio of these two, they are actually equal. So if I rearrange this, I will get this by moving this over here and this one over here, and then I rearrange the subject to become x1. Now this is the Newton Raphson formula. x1 equal x naught minus f x naught over f prime x naught. So if I substitute the value of x naught into this here over this formula, you will get x1, the value here, which is a better approximation of the root compared to the first one, x naught. Now what if we repeat this process? Now by using x1, we repeat the process of the better approximation using Newton Raphson method. Now by substituting x1 into f, and I draw a tangent over this point. Alright, this tangent passing through this point at x1. You can see that the tangent now intercept x-axis at the point even closer to the root. Let's call it x2. Now using the same concept here, the gradient of the tangent, the same concept here, you will get this formula. For x2, you will get it by substituting x1 into this. Now you will see x2 is an even closer approximation of the root. This is where the Newton Raphson method comes from. If you look at this common formula, you will understand that how they get this formula. So when you answer a question on Newton Raphson method, you don't need to show them how you get the formula. You don't have to use this. You straight away use this formula. Alright? I'm showing this visual representation of the Newton Raphson method to make you understand how this method works and how they form this formula. Alright? Now, if I want to go even closer to the root, I have to repeat the process again. Now, what if now I use x2? I draw a tangent. Can you see this time? The tangent at x2 intercept x-axis at an even closer point here. It is very much closer to the root. Let's call it x3. So we use this formula. By substituting x2 into this formula, you will get x3, which is an even closer approximation. Now, if you continue doing repeatedly, you will come closer and closer to the root, right? And once you get two equal answers, then we will take that answer as the root. I will explain further when we try this example. Right, let's go to the first example. Using the Newton Raphson method, with the initial approximation x0 equals 2, find the positive real root of the equation, correct to 4 decimal places. Now, to solve this question using Newton Raphson method, you don't need to draw the graph. Now first you must rearrange this equation so that it becomes fx equals 0. If your equation is not equal 0, you have to rearrange it so that we can let fx equal this part. So we get this fx equal x power 4 minus 2x power 3 plus x minus 3. Alright? Now, to use Newton Raphson method, if you can remember the formula, we need the first derivative, f prime x. So you differentiate f, you will get this. Now, by using the initial approximation here, using the initial approximation x0, we are able to get the first approximation x1 just by substituting it into the formula here. So you need to show the working. Remember, you need to show the working of the formula. Substitute 2 into the formula and then show this working. Now from here you don't need to go further. You just use your calculator, press this, and you get the answer. Write the answer. Now for this answer, take note, it's very important. It must be round off to at least 1 decimal place more than the one requested by the question. If you look at the question asks us to round off the answer to 4 decimal places, correct? Now if the question asks you to round off to 4 decimal places, it means your answer here, you must round off to at least 5 decimal places. You can choose to round off to 6 decimal places, right? But my advice is, if the question asks you to round off to 3 decimal places, then usually this answer I will round off to 5 decimal places, means 2 decimal places more than the one requested by the question. But if the question asks for 4 decimal places, I usually round off to 1 decimal place more, so that I don't need to do too many approximation. Right? Now you will learn along the way. Now 2.11111 will be your first approximation, x1. Now we are going to repeat the process to get a better approximation. Now this time you are going to find x2, which is the second approximation. By using this number as x1, now we will substitute into the formula again. Now this is what you will get. Can you see here? X2 equal, this is your x1, minus, this is your fx1, and here this is your f prime x1. Now you don't need to write further. You use your calculator, calculate, get your answer, and round off to 5 decimal places. You should get this. Practice. Do you get it? Now with this, you can see that it is different from x1. Right? It means this has go closer to the root. Now we go for the third approximation, x3, by using this. Now in STPM, the examiner requested that we must show the working for the first 2 approximation. Take note, listen carefully. For STPM, it is compulsory to show the working of the calculation for x1 and x2. This is the example of the calculation, right? You must show it. Subsequent approximation x3, x4, x5, you don't need to show the working. For x3, you just need to use your calculator, or you draft it on the rough paper and press and use your calculator to get your answer, and you just need to write the answer here. Then use this x3 to go for the next approximation, x4. Again, you don't need to show working. Just substitute into the equation, use your calculator, and you will get this answer. Now, do you notice that x3 and x4, they are exactly the same? Now, once you obtain equal approximation twice successively, then you may stop the process. Means two approximation exactly the same, then only you stop. You must stop. After that, you make a statement. We will take that as the answer for the root. From here, you round off to the to 4 decimal places as requested by the question. Alright, so 2.09774, you round off, you get this 2.0977, put bracket 4 decimal places. Right? Remember, you must put this 4 decimal places. If you do not put this, then this sign you must not put equal sign. You must put approximate sign. But if you put 4 decimal places here, then you can put equal sign. Now class, I only show you one example here. Alright? Now use this, you must practice. Right? Now if you encounter any question, you just WhatsApp me, then I will show you a video for that example so that you can understand better. But for now, I believe it is enough for you to be able to use this Newton Raphson method to solve the question in checkpoint 12.3. If you find it difficult to understand, you may replay the video, listen to it again. Maybe it will help. Now let me show you what it means by overestimate and underestimate. Now for Newton Raphson method, sometimes the estimation that the approximation that we do, sometimes they overestimate. It means your estimation or your approximation is more than the root. That is overestimate. Now let's see the visual. Now if for this case over here, this case as shown in the graph, if I choose the initial approximation, if I choose x0 as 1 here as the initial approximation, now where do you think x1 will be? x1, the first approximation, where will it be? Now how do we know where will x1 be? Yes, by drawing a tangent. By drawing a tangent at this point, because Newton Raphson method is actually using the tangent of here. So if you draw a tangent at this point, you will see that your first approximation is over here, x1. Alright? Can you see here the initial approximation x0 here will give you the first approximation here, which is bigger than the root. The root is here. x1 is much bigger than the root. This is what we call overestimate. So in this situation, your Newton Raphson method will overestimate. Now let's see over here, if it is in this situation and I choose the initial approximation S0, S2, where do you think the first approximation will be? Now you draw a tangent over this point. Can you see the first approximation will be here? So by using Newton Raphson method for this situation, your first approximation will be less than the root. The root is here. X1 will be less than the root. So for this one, we say that the Newton Raphson approximation will be underestimate. Now we have come to the end of the lesson. Now you need to practice what you have learned. Without practice, you will not master anything. So try every question in checkpoint 12.3. Remember, checkpoint 12.3. Please forward your question to me. I will try my best to explain to you, and make you understand. Right? Stay home, stay safe.
We are your children, and we've gathered here today.